to all of you. I welcome every one of you to my YouTube channel, Electronics Engineering. My name is Ria Pal, and today we are going to deal with logic gates part 2. Part 1 video I have already uploaded in my YouTube channel. The link of that video I will put in the description box below. Now, in this session, we are going to study about input and output, what is input, what is output, and how both are related to each other. And if there are many input given to a digital system, how can we make several combinations of input to obtain a desired output? Now on the screen you can see a digital system. Now the digital system can be anything. You can consider a counter, a flip-flop, a sequential circuit, a very simple digital circuit, example logic gate, anything you can consider. Now input is nothing but anything which we are giving to a system, that is called as input. The system will work on that input and it will generate some result, and that result the digital system will give it to us. That result is called as output. In many books you will find input is written as I/P in the short form and output is written as O/P. Now input, I again repeat, input is something that we give to a system and output is something that system generates and give it to us. Okay. Now here is an simple illustration using logic gates. Now see, in the diagram 1 I have used AND gate. Now I hope you all know about the working of AND gate. In the diagram 1 the input which is given is A and B. Okay, so in the diagram 1 the AND gate receives two input. One is A and another one is B. Now the output is marked by y equal to A dot B. I hope you know how to read the output of an AND gate. Y equals to A dot B. Now see the diagram number 2. Diagram number 2 says that there are four inputs given to a AND gate. Now four inputs are A, B, C and D. Now the output is A dot B dot C dot D. By using this diagram 1 and diagram 2, what I am trying to say is, if you are considering a digital system like logic gate, you can have multiple number of inputs, but output terminal will be only one. Okay, see in the diagram 1 you have two input, in the diagram 2 you have four input, but see both the diagram 1 and diagram 2 has only one output terminal, that is represented by a term y. Now diagram third one says that you can have as many number of inputs to a logic gate, but output terminal has to be only one. Now here n is the nth number of input, n number of input. So y will be A dot B dot C dot till n input terminal. Okay, so why I have used here an example of logic gate, because for the upcoming screen which you will see, in that I will be dealing with one output terminal. So for that purpose I have used a simple AND logic gate where I have illustrated that there can be several number of input, but output terminal has to be only one. Now on this screen which you can see is the formula. The formula says that if there are n number of input and y represents number of output. In the previous screen you saw I used logic gate as an example where output was only one terminal. Okay, so here y, which is the number of output, it will be 1 in number. So the number of input combinations that we can make is 2 power n, where n represents the number of inputs. Okay, now this 2 which we have used in the formula, as you can see on the screen, here 2 represents logic 0, or logic 1. You know, in digital electronics we basically use logic 0 and logic 1. We do not use any intermediate level or intermediate state. We either use high logic or low logic. We either use logic 0 or logic 1. For that purpose, we have to write 2, and 2 to the power n represents number of input combinations. That means that in how many varieties, in how many ways you can combine the input so as to generate a particular desired output. So always remember, the number of combinations is equal to 2 raised to n. This is the simplest formula in digital electronics. Now see on the screen here, it's a very simple example. Again, I have taken an example of digital circuit with 2 input and 1 output. The 2 inputs are marked as input number 1 and input number 2. Okay, input number 1 and input number 2. And the output, which is single in number, that I have marked using the term y. Okay, now previously you saw that 2 raised to n is the formula using which we can generate variety of combinations. Okay, number of combinations. So here in the above block diagram we have used two input number 1 and input number 2. So 2 raised to n will become 2 raised to 2. So 2 raised to 2 gives 4. This means that using 2 input we can generate 4 input combinations. Okay, now see the table towards your right hand side. In the table there are 3 columns. One column is input 1, the second column belongs to input 2, and the third column belongs to the output. Now here we are not actually interested in what type of output we will obtain, because we have not specified which type of digital circuit we are using. Okay, so let us ignore the column of output, the last column. Output can be anything based on the selected digital circuit. Now see the input 1 and input 2 column. The circle which I have made using red color, you can see input combination, the first row is 0 0. That means when input 1 is 0 and input 2 is also 0. Now 0 means both the inputs are at low logic. Logic 0 and logic 0 both are at low logic. That means low voltage is supplied at input 1 as well as at input 2 terminals. Now see the second row, 0 1. Now 0 1 is the second type of combination. Now see the third row. Third row indicates third type of combination, 1 0. Input 1 is high and input 2 is low. And see the fourth line where input 1 is 1 and input 2 is also 1. That means both the input terminals which are connected to the digital circuit, both are at high logic level. Okay, so these are the 4 combinations. One is 0 0, another one is 0 1, the third one is 1 0, and the fourth one is 1 1. And always remember, when these kind of combinations are made, always start with the 0. Why 0? Because 0 indicates low level or low logic. Hence, it is always preferred to start with 0. Now, how to make these 4 combinations are, we know that we will get 4 combination as 2 raised to 2 equals to 4. So 4 combination, in the first column you will write 0 0 1 1. Okay, and in the second column you will write 0 1 0 1 in an alternate ways starting with 0. Okay, so the 4 combinations which you got is 0 0 0 1 1 0 and 1 1. Now beyond these combinations you cannot make the fifth combination out of this. Why? Because the combination formula is 2 raised to n. So here, since n is equals to 2, so 2 raised to 2 is equal to 4. We already got an answer 4. Hence further combinations cannot be made. I hope this topic is very clear to you. What is input, what is output, and how to generate input combinations to get a desired output.